everybody, and welcome back to another segment of Blythe News Report. On today's episode, we'll be diving deep into the effects of the HBO equilibrium, as well as inspecting the impact of high-altitude sickness. The first topic we'll be discussing is hemoglobin. According to Laura Martin of the National Institute of Health, hemoglobin is a critical component of red blood cells and is composed of protein called heme, which aids the transportation of oxygen throughout the body. On this side of the screen, we can see what red blood cells look like inside the body. On this side of the screen, we can see what hemoglobin looks like inside of the red blood cells. Referring back to the protein heme, you can see what the chemical structure looks like up above. Continuing from the lungs, hemoglobin binds oxygen to itself and carries it to the tissues where it is released. The cycle occurs again once hemoglobin travels back to the lungs. This is known as the HBO equilibrium. Before we dive any deeper into our scheduled programming, I would like to take a moment to review a chemistry concept for our viewers. This is called the Le Chatelier's principle. According to Jim Clark from the Chemistry Guide, if a dynamic equilibrium is distributed by changing the conditions, the position of equilibrium moves to counteract the change. Depending on the stress that is applied to the equilibrium, there will be a right or left shift in order to compensate. As displayed on the screen, you can see Le Chatelier's principles equation. Returning back to our scheduled programming, according to Jill Frankel of Science Clarified, when hemoglobin reacts with oxygen, oxyhemoglobin is formed. The oxygenation of blood is an equilibrium reaction. This is a form of dynamic equilibrium because it establishes a balance with the movement of hemoglobin. Therefore, the synthesis of oxyhemoglobin, a forward reaction, and the decomposition of oxyhemoglobin, reverse reaction, can be displayed in the chemical equation provided on the screen. Both high and low altitudes control this equilibrium system. The air pressure and the amount of oxygen needed to survive directly correlate. When a climber begins to reach a high altitude, there is a decrease in gas pressure. According to Le Chatelier's principle, a decrease in pressure results in a shift to the side with more gas molecules. In this case, it will be a shift to the left since as pressure decreases, volume will increase. In this case, it will be a shift to the left because pressure will be decreasing and volume will be increasing. In order to reestablish equilibrium, and more gas molecules of hemoglobin and oxygen will have to be present. Therefore, low air pressure will result in less demand for oxyhemoglobin and more demand for hemoglobin and oxygen to be present. According to mechanisms of hemoglobin adaptation to high altitude hypoxia by Storz J. and Moriyama H., individuals who are born and raised in high altitudes will have their bodies reestablish equilibrium shift by producing more hemoglobin, which allows for more oxygen to be bound to the heme protein and thus cause an equilibrium shift to the right. One of the many side effects of being prolonged in high altitude is something called altitude sickness. One of the most common forms of altitude sickness is when a climber reaches a higher point on a mountain coming from a low altitude. According to Anne Pointer, Kathleen Romito, and Adam Husney from the HealthLink of British Columbia, some symptoms may include a headache, loss of appetite, feeling sick to your stomach and nauseous, feeling weak and tired. In certain cases, some do not have the energy to eat or do anything, waking up during the night and not sleeping well, and feeling dizzy. The most highly recommended treatment plan for altitude sickness is to go to a lower altitude. If the symptoms are super mild, the individual might be able to stay at the new altitude, but need to give themselves time to adapt. If the individual does decide to stay at the high altitude, it is highly recommended to drink lots of water and no alcohol. It is also recommended that you do not go to a higher altitude until your symptoms have passed. This can take anywhere from 12 hours to 3 to 4 days. According to Medicine and Mechanisms in Altitude Sickness by Koot J., a doctor can give acetazolamide. This speeds up how fast your body gets used to higher altitude. You may also use a specially designed pressure chamber to treat altitude sickness. In our final segment, we will be looking at a Canadian connection. Shira Shah Chlorfine was a Nepal-born Canadian woman who died while descending from the summit of Mount Everest in 2002, only 250 meters away from the fourth camp. She unfortunately died what was from believed to be a mixture of exhaustion and altitude sickness. And that concludes the episode for tonight of Blythe News Report. Tune in next week on an episode all about antioxidants. I'm your host, Claire Barnes, and have a good night.